and welcome to another episode of the Mining Conversation with MsTedy. And this podcast is partly sponsored by Vinest, and today we are going to be speaking to the spokesperson of DetNet, and he'll take us through digital mining and automation. So before we start the conversation, I first would like to thank my team, which is Tsepo Munyamani, Kele Khatebe, Gamu Malangabi, and also mention that, or I did mention that the podcast is sponsored by Vinest. So please do not forget to subscribe, like, follow, share, so that you do not miss any of our episodes. With that being said, Mr. Vinesh Naidoo,
correct.
Welcome, and you're a Global Market Support Manager at DetNet. Wonderful. Thank you so much for inviting us to this, what is it called? So it was great. So just to ask you the first question, please give us the brief background of what DetNet is and the impact across the industry.
Okay, first of all, thank you very much for the opportunity. DetNet. So DetNet is a 50-50 joint venture between ACI Mining and Danny Nobel. So we are a technology development house for electronic initiation systems for those two companies.
Okay, wonderful. So your innovation in underground mining continually assist operation to significantly improve their production and cost efficiency. Please outline how inefficiencies in mining operations can lead to massive financial losses and which areas are most likely to suffer from such inefficiencies.
Wow, that's a long question. Okay, so the easiest form to break rock is blasting.
Yeah.
Right. So you have to get the basics correct when you come into drilling and blasting. So your mine efficiencies can start with regards to your ledge preparation, your ore designs, your explosives type, your initiation type as well. So the very choice of your initiation can impact the outcomes of your blast results. For example, with electronic initiation system, you can design your blast timing to be very specific for the environment that you're working in as well. The blast fragmentation does impact the downline activities that will include your loading, your hauling, your crusher, etc. If your fragmentation is not correct, the downstream impact will be in higher cost to mine the product, to move that product as well, and it can have indirect costs to your operational activities.
Okay. So please outline the importance of automation in the modern mine and which machinery, equipment and system is it most appropriate for.
So with our technology as well, we have the cyber-dead system. It's a wireless detonator technology. There we see an advancement when it comes to automation in that environment. Automation, when it comes to charging up underground, removes the person from unsafe working practices. So from a safety point of view, it's a huge advantage in terms of removing personnel from dangerous working conditions. Also with regards to autonomous charging and loading as well, we are faced with potholes in our coal environment. Removing personnel from those dangerous activities, we can eliminate that with autonomous loading and charging of those potholes, and that is made possible now with the wireless detonator technology.
Yeah. So when we were doing the tour at that tunnel, with there was a rock, grid, writing, and things that blade. So how would that then work with that? Is it the same thing?
It's two different technologies. So in the tunnel that you saw, we have the wired technology.
Yeah.
This is the detonator, and it's wired. So communication to the detonator is totally with the wires that connects to the VCU as well. So it will send the signal via the wires to the detonator to initiate the detonator. So that whole system is wired. With the wireless detonator, there's no wires, nothing. It's completely wireless. Inside the detonator, inside this wireless detonator, you have a receiver. Communication to to the Saturday is completely wireless. We call it TTE, which is through the earth communication. So that can communicate through rock, water, air, anything.
You just send instructions digitally, and then that's what it needs to do.
Correct.
Without the person being there or
Yes.
close
To
to
physically connect the detonator
Yeah.
and stuff.
Oh, okay. Thank you for that. And then, is BlastWeb II a game changer? If so, how?
It's a step up from our predecessor, the BlastWeb I system. The capabilities on the system as well is it can now initiate the wireless detonator. It provides active monitoring of the activities taking place underground as well. So you have live feedback of detonators connected. If you have any problems with the system as well, it'll give you live information in terms of we have a problem at this blast control unit underground. It allows the user to immediately address the problems underground prior to blasting. So in a mining environment, the last thing that you want is a lost blast, a loss of productivity. So prior to blasting, the user can check on the service blast controller, make sure that all the detonators are correct, everything is connected, and then they can proceed to blasting.
So, please tell us about the importance of sustainability in the blasting and explosive industry, and what DetNet is doing to make this business more environmentally friendly.
Right, we're looking at greener technologies, greener detonator as well, and it's all part of our development of DetNet. Looking at more sustainable mining, we're looking at removing people from dangerous working conditions as well. The applications of the CyberDet as well is that it allows you to pre-charge blast areas. So an advantage of this is that CyberDet comes or operates functions with an encryption key. Each section of the blast is encrypted with a unique key to authorize for blasting. What it means is that in an underground environment, if you're doing ring blasting, holes can be pre-charged and be loaded and wait for the correct time to be blasted as well. In these type of events, it removes personnel from dangerous working conditions, from working under droughts, etc. So it improves the mine's efficiencies, and also it's a huge safety impact as well.
Thank you. And what innovative techniques or technologies do you use to enable such sustainable practices?
The technologies that we have available, which we emphasize, is the CyberDet system. We also have software designs that influences and impacts the blast outcomes as well. So with our tools such as ViewShot, it allows you to plan your blast quite accurately. You can simulate your blast outcomes as well, and you can tweak it to make sure you optimize and get the best results from your blast.
So what are the main challenges standing in the way of effective implementation of automation solutions in the mining sector?
Well, the cost of automation is a challenge. The second thing as well is in terms of the actual implementation in these environments. It's got to be a collaborative approach from the mining, from the mining houses. There has to be a need for it. It's got to be a benefit of using autonomous loading, for example. Where we see a application currently, as I explained, is in the hotel environments. There has been previous incidents where people were exposed to hotels. There have been fatalities in these type of applications as well. So working in those type of operations where you can remove people out of those dangerous work conditions and charge autonomously would be a huge advantage in this industry.
And what would you say are some of the key benefits obtained from implementing automation technologies?
Safety once again. Also in terms of no loss, making sure that we are able to continue mining in dangerous working environments.
So how important is advanced analytics and AI in regard to implementing effective automation solutions?
It's more about learning our processes, how better we can do things, how better we can manage things as well. It's a continuous learning phase for us. We have the technologies available. It's a matter of integrating and utilizing the information to see how we can improve on what we do. The technologies are available. It's a matter of implementation and making sure we get the outcomes and the results.
And please provide us with your views on how properly leveraging data can help to future-proof the mining sector.
This comes back to utilizing the information to better improve the mining. For example, with our systems, we are able to get information in terms of the number of beds initiated, the areas that you blasted as well. That can be linked to your productivity as well. Also, with the blast outcomes, there is tools that are available to look at your blast outcomes, looking at your fragmentation as well. If we can feed that information back into your design phase, you are able to calculate and work out, is this the best fragmentation that we need? How do we optimize this? And that can be done at the very start of your blast design and preparation process. Also by changing your explosives, changing your timing, that can influence your fragmentation as well. All those factors has an impact on your downstream activities.
So just another question, like for a student who's maybe watching this podcast, or somebody who wants to get into the mining industry and now they are interested in hearing what we just spoke about, and they are interested and they want to maybe work with you guys. Do you have any programs that you do with young people who are in universities or high school students? Because I asked this when we were listening to the Professor Zwane, the professor, he said that what is it for this high school student to come into this, they need A plus or A's in their report, all A's, right? So now I'm thinking maybe a student is sitting at home and watching these interviews and they want to get into this and they would like to know how do they then work with you guys, or do you only work with people who've graduated, or do you have any programs that can introduce us to students to such knowledge?
I think it's a starting point as well. I mean, students are welcome to visit DetNet, see what we're all about as well. ACI has a careers day where they openly showcase the products, the capabilities, the technology as well. Also, what we have done as well, Blitz University has a career day where we come through, we have a stand where they can ask questions, discuss our technology, and also opportunities at DetNet as well. We're always looking for software developers, electronic engineering students as well. So they are more than welcome to contact us and see how we can assist them, or even share with them exactly what we do in this mining industry.
So thank you so much. That was a lovely interview. And again, thank you for inviting us to this talk and tour so that we can see how technology is improving in order for the mining industry to get better as well. So thank you. So that was Vinesh Naidoo. He's a global markets support manager at DetNet, and I just thanked him for the interview, and also still like to thank Mina for sponsoring the podcast, and also thank my team, Tepo Munyani, Kamu Malangabi, as well as Gele Khadebe. And with that being said, please do not forget to like, share, subscribe, and watch the podcast so you do not miss any episodes. Thank you so much, and goodbye until next time.
Please help yourself. There is a strap at the back, you can adjust it accordingly.
Thank you.
deploying this BlastWeb II within our existing systems, and existing projects. So one of the key things that we have in the facility is the underground navigation. You all use your Google Map this morning perhaps to come to the university. So the idea was to use the same GPS technology in underground environment as well, but it's quite challenging, to transfer the satellite signals underground. We got the system from China, which is Beidou, parallel to GPS, but it was very challenging to transform that technology in an underground space. So what we did at DigiMine is what we call the VPS system. It's a visual positioning system. You can see that we have different QR codes throughout the facility. So what you can do, if you have the DigiMine app on your mobile phone, you can just use the app, open the app, scan the QR code. Once you will scan, the system will locate you in front of the QR code. Once you are located, then you can just put your mobile phone like this, and you can use it like your Google Map. You can choose where you want to go, Refugee Bay A, BlastWeb II, Site C, A, B, Shaft A, C, wherever you want to go. Your phone will guide you, turn left, turn right, and so on. This is what we call the VPS. The biggest challenge for the VPS was how to convert the 2D environment into a 3D space. Of course, we have the scanners. We have the MapTech scanner, which is very costly. It costs around 2.5 million rand the scanner, and also we have to spend a lot of money every year to calibrate. But the scanner has a job to do, and the job is to have the precise 3D modeling. But at the same time, it is also not feasible to deploy 2.5 million technology in a challenging environment all the time. So what we did at DigiMine, we came up with our own system. So this space that you can see here is not a video. It's a 3D model that we build again using your mobile phone. So you can just use your mobile phone, take the 2D pictures, and we build the algorithms which stitch those 2D pictures into a 3D model. And this is engineering dimension 3D model, which means that you can take the engineering measurements up to centimeters from the same model. And this research is very important because once you have this 3D model, you can basically see the geometry of the mine, you can see different features in the mine, and at the same time you can also plan how to do the blasting as the phase will forward, as the tunnel will forward or move forward. You can also plan how you're going to mine. At the same time, you can also multiple scan to analyze the fall of ground environment, pre and post blast as well. So this is also something that is linked to the VCU system as well. Just like this, we go this side. This now. Perhaps this is the most clean and well-managed underground facility that we have ever seen. But it makes sense because it's a block mine and we do use it for different R&I purposes. Alright, so this is the next tunnel. This is a 7 meter in-length facility, 3 meter width and 3 meter height. There are more than 60 systems in the facility. All the systems are operational. Because of the time I will not go through all the systems, but some of the systems that have also been built in-house by the team of DigiMine students in collaboration with different faculties across the world. I think one of the things that I would like to highlight is that this facility is not only used by mining engineering students or mining specific research. This facility is used by several other faculties. For example, students from Geosciences, Faculty of Sciences for geological mapping in an underground environment. The students from School of Geography for GIS mapping purposes. The student from Humanities to understand how the light impacts, in different environmental conditions for workers. But at the same time, the doctors from medical as well. They also use the facility to analyze the impact of the different EM radiations in the confined space on the humans as well. So it's a multi-purpose facility. Beside that, this facility is also used by several tech service providers throughout the country and also from international technology providers. Last year, we did more than 16 international technology demonstrations in this facility. And out of 16, there were 7 drones from United States, Turkey, Finland, Spain, many other countries as well. So this facility is a multi-purpose facility. This side, please. Okay, so this is what we call the LiFi of the human, which I explained basically. So these are the ordinary light bulbs, and we are using the light along with the power lines, electric current. We are using the power line in fusion with the light source to transfer data from underground to the surface. We have successfully transferred the text messages, voice messages, and live video just using the lights and the power lines. So how it will work? Again, your system, in this case your mobile phone or a machine, needs to have the Digimine app, LiFi Digimine app. Once they have the application, this is what's called the hotspot. The moment they will pass through this hotspot, the information will be sent or picked up from the device to the control room, and it's a two-way communication system, which means that the information can be sent from the control room to the underground or to the source. It will park here. The moment that particular asset will cross this hotspot, they will receive that particular message. Now, this is something that we really think is the future of communicating with the machines as well, because machines has lights. So how we can communicate with the machines with the lights? So this is the language to communicate with the machines, which we are exploring at the moment. At the same time, we are also exploring how we can link it with the lamp on the hard hat, so that you and me can communicate or send a message to one another without saying a single word. That is basically, and that's what I think that with this wireless system and the new BCU that you have from DetNet, because the new system from DetNet, it supports hybrid communications, it supports different sort of communications. So perhaps this is something that we will explore in the future, how we can link the LiFi on the BCU to make it more hybrid in terms of communication from underground to the surface. This side, please. So here we are in front of the blasting phase. I will try to explain the DetNet system in front of the DetNet team. But okay, so this is the blasting phase that we have, and this is the system. This is the these are the detonators, of course, dummy detonators with the LEDs, and it is linked with the BCU2 BlastWeb system, which we will see shortly. I think currently the focus of the research and the teaching and learning is twofold. The first is that we are using this particular system in a simulated environment. So students can set up different blast patterns, and based on different blast patterns, they can get the results or the reports in the computerized environment. The ultimate goal is that how we can optimize the blast conditions based on those simulations. In the simulations, they can set up different geological conditions, the hole depth, its width, the quantity of the explosive, and so many other things. Because we know that blasting plays a key role. Like for example, your fragmentation, your rock and your ore, the ratio, the size of the rock. There are so many other things that are associated just with the blasting. So that is basically where we are using the BlastWeb system to optimize those blast conditions, but it's beyond those blasting things. As I mentioned in my brief, that in future with this new BlastWeb II, our aim is to focus more on the green blasting. At the same time, how we can have more optimized geotechnical conditions in underground. Imagine that you all are here. If we do a blast here, with the blast there will be a shock wave, and then that wave can cause a damage to the roof, and then we will have fall of ground. So that is how we can optimize this whole thing in real time. So that will be the future. At the same time, as I mentioned, teaching and learning is the key aspect of the system as well. The students, not only from School of Mining, but School of Geosciences and other faculties, they do come here and they do appreciate the system that we have here in terms of getting the hands-on experience and to have first-hand experience of the practical side of this blasting as well. Because as I mentioned, the blasting is not just to blast the rock; it has multiple other sort of associated features that needs to be catered before you can do actually a blast. So that is basically where the research and the teaching and learning right now we have. So we will have a demonstration in this facility. For that demonstration purpose, we are going to switch off the light. So don't worry, you are in safe hands. These are dummy detonators. We will do a demonstration of the blast. And why we need to switch off the light? So that you should be able to see those LEDs. Because students can set up the patterns. Once they will set up the patterns, the LED will blink according to the pattern. And I think for purposely, we have reduced the time of the LEDs so that you can actually see. And this sound is not an emergency evacuation sort of thing. It's just for the blast. Alright? So, Farai?
Yes.
You will let us know when you will switch off the lights, right?
Okay, yeah. So once we switch off the lights, we're going to let you know within how many seconds we have to check out the plastic face so that you see the face. Okay.
So you need to be more focused on this side. Meanwhile, if you have any questions or any thoughts or anything you want to share, you're more than welcome.
So at the current moment it's still charging, and then afterwards when it's reloading, that's when we switch off the lights, and then I'll tell you to check, and then you'll see the pattern.
Something to add.
Yeah, please.
Just for your information as well, these are electronic detonators, fully programmable detonators. So when you get the detonators, there's no delay on these detonators.
Sorry guys, so in 5 seconds you have to check that time.
So these detonators can be programmed anything from 0 to 20,000 milliseconds, and they've been, there you go.
Boom.
No bang.
Yeah, please continue.
Yes, so what I was saying is that these detonators are fully programmable detonators. You can program any delay from 0 right up to 20,000 milliseconds in 1 millisecond increments. So a nice thing with a fully programmable detonator is that you can optimize your blast designs based on your tunnel profile, your tunnel designs as well. That can be customized for the optimum results for your blast outcomes.
Okay, so that is basically how the students, but once they do the blast, so there are two things. The one is the blast from this PCU that we have. So the student did a blast from this PCU. But at the same time, we can also do the blast through the control room, which is the remote operation. So you can also do the blast remotely as well. So you don't need to be in that facility to do the blast. So you can also do the same blast from the remote facility. And these LEDs are also linked with that simulated environment as well. So they can see the same pattern that they set up here in the simulated environment. So this is basically where we are exploring the grounds where we can actually link that pattern with our geotech system, because we have state-of-the-art numerical models in the facility which can do the geotechnical modeling for us. So how we can link that blast with the geotech system? So once you do the blast, almost in near real time you can get the data in the geotech system. So the geotech system can do the modeling, and they can tell you based on this blast and geometrical conditions, these are the hot spots that you need to be very careful of, and which are at the risk of fall of ground or something like that. Okay, we'll go that side. So this is quite compact and it has more features. So as I said that and one of the things for us is that we don't do research in isolation. So for example, if we will do research on the BlastWeb, we will incorporate DetNet in that particular research. So that we can actually feed back to the industry in terms of this research and development. I think if you noticed during the presentation, it was mentioned that there's a specific card and there's a specific key that needs to be dealt with high security and high clearing. So Fry, he has that particular card and password and everything. He has the key for this as well. Even I don't have that. So and no, it is very important because at the same time we do practice the safety as well. So we want the students to know that it is really very important. They need to deal this thing with the utmost responsibility. So they have all of those things. Once the student will leave, we will train the new student, and that's how the research will continue in the facility. We are actually hoping that we will have one new student who will continue with this green blasting research going forward, perhaps later this year, quarter 2 or quarter 3. But once we will have that, then we will have more hands-on thing on this thing with BlastWeb II. Any questions? Okay, quickly. Yeah, this is. We'll put some water here to give the real feeling of underground. Okay, so this is the working stove. Just quickly, again, this is basically an operational stove, but the different part is that we have actually installed the sensors inside the stove. So you can see that we have installed the sensors in the support structure, and the idea is again that students can basically do some minor movements in the space. The movements basically we record those movements in the geotechnical models, and ultimately the goal is to optimize the stability conditions in underground facility. One of the research, and that's something that may be linked with the BlastWeb thing, is that we have what we call the drones research. So we are working on the drones as well, the UAV systems in the facility. We have different drones, and other key research that is happening in this space is that how we can use drones as antennas. So imagine if there is no network, there is nothing for the BlastWeb, you can use this drone as a router to connect your remote operations to the control system. And that is something that is happening with our partners in the Europe. But with the research that we are busy is, we are using this drone for environmental recon. Like the drones can go in these narrow environments, they can collect different environmental conditions, for example, your temperature, humidity, your dust concentration, your gas concentration. But at the same time, the drones used for different 3D modeling as well. This particular drone has been trained on my gestures and my facial recognition. That's why I have to remove the cap, because it does not recognize me when I have the cap. And I cannot increase my beard as well, because I tried that once and it failed to recognize me. I trained this guy and it failed to recognize me. So this is something that we would also like to explore going forward, how we can integrate these different systems, together. Because the ultimate goal is to give the right information to the right people for the right decision making at the right time. Thank you very much.